chair is in the shot. Marginally better. Hello, everyone. Tonight is a night of programming. Welcome in Rage, David, Willow. I hope you are all doing well. Tonight is the big night that we're finally getting around to rewriting the camera handler system. It's bad. It's a pain to actually work with. We're gonna simplify it, but also make it a little bit more extensible and maintainable. I've got a pretty good idea of how we're going to do it. We're not doing the paper airplane setup today. That's something that's going to require me to learn a lot more about animation in Blender. Like, I'm worried that will require me to learn about skeletons and stuff. Stick vortex versus angle. Oh, vertex. Yeah, the controller thing that I was dealing with. So let's get out paint. So what I was dealing with was you got your controller, and somewhere in that controller is your the location. Let's actually make a little X here. There, beautiful X. Okay, so you've got this location that represents where on the controller you're tilting. Okay, so you can tilt up or right. You can slide it around the outside to rotate. So the angle that I was looking for would be like 0 degrees over here, 45 degrees up here, 90 degrees up here, all the way around to 360, which is 0 again. Vertex refers to coordinate system. This is 0, 0. This is 1, 0. This is -1, 0. This is 0, 1, and 0, -1. Maybe the vertical is flipped depending on your coordinate system. And you can go back and forth. Like if you have the vertex of like, oh yeah, that's 1, 0, you can very easily switch to an angle by using the trigonometric function arctangent. Most math libraries will include 2 different arctangent functions, and commonly arctan2 takes as a parameter a y value and an x value, and you just pass them in that order, y, x, not xy, as you might think. And then it will do the math and give you what the angle that represents is. Now, if you just have an angle, well, let's say I have an angle of 90 degrees pointing straight up. Well, I can't 100% tell for sure what position that could be, because it could be here, 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 but we can map it onto a certain radius to go back to that. And so if you have the angle and you want to go back to the vertex, it would be, your x value would be radius times cosine of your angle, and your y value would be radius times the sine of the angle. So there you go. There's your little trig. Anyway, professional. I don't know about that, Willow. I guess upon technicality, I am in fact a professional game developer. I have made $100 off of video games. Makes more sense. I feel like having a good grip on trigonometry helps immensely with game development. At least any game development that involves physics or drawing something to the screen, because you're going to be dealing with angles a lot. I mean, probability is also helpful to know when you're dealing with anything randomized. Trig was my weakness. Up to a point, I did pretty good at trig. And then it just started getting into a lot of like memorizing identities, and I kind of slipped a bit. But I still maintain just being able to think about angles and relationships between angles and circles. That's all you really need. Basic trig. But you need to have it really solid in your head. I mean, it helps just to have a diagram pulled up if you've got if you're not fully there on trig. No shame in that. Okay, what is the horrible crime, Willow? Arson? Because honestly, depending, maybe that's not too bad. All right, our camera is going to have... We're actually going to have two new classes here. We're going to have camera, and we're going to make a global for a camera manager. Or camera handler? Camera handler. And this one is going to be an auto load, which is to say a global. There we go, so that we can access it anytime we want. And it can just have some static functions. So it's going to have a static property. Which is just a camera. And that's going to be managed by the scene manager, which is the one that is typically going to be creating the camera. Add camera right here. Camera node. So whenever that happens, our camera handler.camera, we're going to make sure that it's the camera node. So there we go. Every time we add a camera to a scene, we're going to be able to keep track of it. Now we have a global. Oh no, the chew bone. That is actually kind of a big deal. The arson was going to be forgivable, but now you got problems. Okay, so camera is its own object. It's not parented to the player object. So I think what we want, and I need to decide if we need to, basically the idea is we are going to manually handle transitioning between object positions. So you've got different, let's see here. Let's think of them as different accelerations towards, between objects that you can do with tweens. You can do linear, which is just, it goes the same speed the whole way across. Then you've got things like your typical lerp, which starts fast, and then slows down as it gets closer to the target. You can do cubic, where it starts slow, speeds up, and then slows down again. And all kinds of variants. Actually, there's a really good chart. Here we go. That explains all of this. The tween cheat sheet. So each shape also has 4 variants. You can they're these color-coded variants. I would like to see if we can expose these actual curves to where we can kind of use them without actually using a tween. I have a very good reason for not wanting to use an actual tween. We'll get into that later, perhaps. But what we'll do to start with is probably just do linear. But we want to make sure we track where the last object that we were targeting was and the next object that we were targeting is. and we give it a time to tell it, okay, I need you to move between A and B over the next 2 seconds. So take a nice long, leisurely 2 seconds to change what you're focusing on. And then that becomes the only thing you're focused on. And we don't care about this at all anymore. And then when I tell it later, okay, focus on this, it'll say, okay, now I've got 2 objects. I've got my from and my to, and I'll transition between them. And then when I get there, after X number of seconds, then I don't care about this object. What I do need to think about is, do I just care about a from and a to? Do I also need to have special handling for player? Probably not. Probably not, actually. Yeah, let's just, and just for ease, let's keep a singleton instance. So that on ready instance is self, then that should be it. We never knew this object up, so that should be it. And that way we don't have to deal with everything static. No, let's not do that. Let's just do everything static. It's fine. It's fine. We will need a process function. We're going to keep track of a previous or from target, which is always going to be a node 3D, which will start as null. Well, thank you for that gigantic dino dance. Gosh, how big it is. You know, it's got something interesting going on that I've never really noticed before, which is just that slight gradient across the top. Wish they made him in purple. Why does his nose blink? I always read that as the eyes, since they blink. I think that's the reason I read them as eyes. But that's clearly a snout with nostrils. And the big eyes on the side instead. Which, I don't know, maybe I thought those were ears or something. It's fine. But he's got a cool little gradient at the top. And I wonder if we added something like that to our character sprites, if we would get something that looks a little bit more like it has depth to it. None of the other sprites signify their breathing, so I have no idea. Oh gosh, look at all these lizards everywhere. We're also gonna have a current or a just a target. I guess from target can be old target. Now that's not gonna be all there is to it, because old target might get deleted, and if it does, we need to also keep track of old target position, which is going to be a vector 3. I better comment this, because I am going to forget a lot of this. In case old target gets deleted. Use this for tween calc. For all occasions, we could have holiday lizards. Do you know that there's different variants of the intro for different holidays? It's true. Current tracked object. So I think the old code had this thing going on where you could tell it to go look at a specific position. And I'm not going to do that anymore. You always need an object. It can be a dummy object that's just there to have a position for the camera to follow, but you have to have an object now. Let's see here. We need current transition time, I guess. I want that to be a float. Current ratio. No, let's go with the actual time. Let's go with the full time. We can calculate the ratio. How many seconds? Since leaving old target. And then we have, let's say, yeah, transition duration. How many total seconds to get from old to new target? So this is going to be when we're setting things like, hey, give it 2 seconds to get from A to B. That's where the 2 goes. What else? What else? Position target. We're going to be storing the camera's position, of course, and its rotation. I guess old target also needs rotation, which is going to fall in the same boat as position there. We're going to store it. We're actually doing it, Germ Dub. We are working our way back through time. Every 24 hours, we're scooting back just a few minutes every night. Slow but steady. We're already at a solid 30 minutes, which bodes well for the coming week. The side effect is that she's winding up with a huge amount of extra time for getting ready in the morning, which she's not going to have next week. It really is, Willow. It really is. Okay, are we going to track... is in transition? Do we even need that, or can we get by with just the current transition? Yeah, yeah, we need that. All right, so process. The very basic setup. Global position? Extends no... Oh, wait, what is this? Oh, I'm on the camera handler. I guess I don't actually need that, do I? Do I need this to store this? Or can I have... I think all of this can go on the new camera code. And this does not need to be static then. Okay. So now we begin the processing, which is going to be very straightforward. Global position equals target dot global position. Easy. Scene manager. Camera node does not actually have player anymore. It's now going to have target. Or what did we call it? In our new code setup, just target. Target equals player. Player node. Okay, so this is pretty crappy, but it's the basics. Can't set a character body 3D. Oh, right. We didn't actually set up our camera scene. We're gonna remove the old code and plop on the new one. All right, here we go. All right, so right now we're setting it. Hey, we're in first-person mode. Did you guys know that? We are in first-person mode, basically. Great. Hi, Day. All right, so that's the basic code. We do want an offset from our target position. Now, here's the tricky thing. This kind of means that whenever we are telling the camera to focus on something, we're actually telling it to move to a point that's like pulled back from that thing. Which is not always what we want, but it's what we're gonna go with. So the old code was pretty simple in that it just had a distance to target. And we're gonna stick with that, of having kind of the same base distance to target. Now it also kept track of like a far and wide camera, all this other stuff. Distance to target. Here we go. Distance to target. That's what we're gonna go with. So we're gonna say, do this plus distance to target. Hey, nice Day. Very exciting. And then we need to make sure we are starting on the right scene. There we go. Okay, so now we have the basics. Now you will notice that it is following us upward on jumps, which is not good. We're gonna fix that, but this is a good start. We are back to the barest bones of camera management, which is a good start. Reality is bizarre. I think we want a bool for... Do we want to have a separate object that always follows the player? That can act as a camera tracking point? That might make sense. Suppose that the player managing code has a little bit in it that just adds a dummy node, and that node always follows the player exactly, but it also does not rise while the player is in the air, and when the player is in the air, it zips up, and that way. That would be nice. You know what? Maybe that would be a good thing to have. A child node, node 3D, camera point, camera focus. And it's just a node, but it gets its own little script where we monitor the player's position. And so camera focus is just gonna say, global position equals parent dot global position for now. And then when we are setting what our target is, we're not going to say that. We're instead going to say grab the camera focus and follow that instead. So X is always going to follow X. Parent is going to be a character body 3D. We'll do a little bit of a ready up here. Y'all ready? Where we tell it parent is parent node 3D, and that way we don't have to call this function every time. We only have to call it once. So X and Z are going to follow at all times, whereas Y, if global position dot Y, if we are okay. If the Y value, if we are above the player, if the camera is too high. Oh, he's good as always. If the player is too high, or too low, and the camera is too high, then just bring the camera down to match. This is for when we're falling off of a ledge or something. Otherwise, we have to check to see if we're on the floor. If the robot is on the floor, then yes, bring the camera up with a lerp. And if not, do nothing. Don't scroll camera upwards when player is mid-jump. That should do it. That is that. Let's test that next. So tonight's plan, for those just coming in, is we are rewriting the camera code. So far, it looks pretty similar to what we already had. Oh, that's the opposite of what was supposed to happen. Why is that the case? Why is this happening? Player, camera focus. Let's watch its position. Oh, wait. Its position is just matching the player exactly. Just always. Regardless. It's never not the case. Even now. So it feels like it's always going up. Print, move cam down. And this is gonna be move cam up. And this is gonna be don't move. All right, let's see what's going on. Why isn't it doing the thing I just said? All right, it's trying to move up constantly. Okay, that says, well, it's properly getting the don't move. You know what? It's because it's a child object and it needs to be top level so that it does not move as the player moves except by the code that we're doing. Uh-oh. I didn't like that. Parent is now null. Huh. Why? Why? Why is that? Is that really a thing? If you do... Oh yeah. I guess if you do top level, you just don't have a parent anymore. Scene Manager should allow us to handle that manually. But that's weird. Sorry if that's just the way the cookie crumbles. Let's make this an export, and then we can just pull it in this way. Just say, all right, there we go. All right, do we get it now? Do we get the vertical movement I want? Yes, we are not scrolling the camera vertically until we land on the chest. Yep, and then it snaps up. Great. A little bit snappy, perhaps? Maybe a little too snappy, but that's the right idea there. So let's slow that snap down. And let's slow this down as well. To the same degree. Let's expose a variable called vertical lerp ratio. Set it to 0.1 so that we're not repeating this with a magic number. Suikoden. What happened there? Oh, I jumped into a zone. There's a zone in here. Yeah, and I've broken the zone code because we're rewriting the camera, so that makes sense. All right, that looks much closer to what we previously had. I love it. However, it can't handle our updated camera code cannot yet handle rotated cameras. We will get there, but it can't do it yet. I feel like we're doing pretty good here. We're scooting our sleep schedule back. Who is pinging me? Why am I getting pinged? Oh, GermDev went live. I get it now. It's like, why is this red indicator mocking me? We got the time change next week, so we are desperately trying to get ahead of it, which means going to bed a lot earlier and theoretically waking up earlier, but I've not really been doing that part. Time change is this weekend, Sunday. Got to wake up an hour earlier. This is how you find out. All right, so camera new. Now we can do that. Yeah, let's go ahead and fix the camera rotation stuff. So camera control zone is a mess. So it is supposed to allow us to set a different rotation, like a different thing to rotate to. So that, like, while you're in this zone, the camera is shifted 20 degrees, for example. Alternatively, while you are in this zone, we are pointing to a different target. And while we were in this zone, different lerp rate. That I don't like, and we're gonna get rid of that. I just don't know exactly what it's gonna look like, so I'm gonna comment it out for now. Lerp. Good question. Let's talk about lerp. Lerp, short for linear interpolation. So say that you have an object over here, and you want to move it to this object over here. And remember, we're thinking in terms of frames. This is not something that actually happens in time as we think about it. This is something that happens in code cycles. So one way to do it is say, hey, I want this to take 5 seconds to do. Well, then whenever I run my code to update the position of my object, I can say, all right, it's been half a second, therefore I should be 1/10 of the way there. Now, later on we run the code again, it's been 2.5 seconds, therefore I should be exactly halfway there. And the effect there is you get a linear movement where it moves in a very constant speed until it gets there, and then it stops. So lerp is a way of adding a little bit of, let's say, pizzazz to that sort of movement style. Instead of saying, get here in 5 seconds, we instead say, all right, every time you run this code, I need you to close the gap by 10%. So the first frame, it'll move 10% of the way there. The second frame, it will move 10% of the remaining, which is 9% of the way there. And then 10% of that, and 10% of that, 10%, 10%, 10%. And so the effect is, instead of getting a constant speed movement, what you instead get is something that more looks like, where it starts off very quick and then slows down to a stop. Although if you believe Zeno and his arrow, then it never even gets there. Yes, exactly. It is the poor man's ease out. Now, it's not a true... It looks almost identical, but it's not doing the exact same math that you'd see. But yeah. Now, the thing is, it's not just for movement. You can do that with any value. Any value can lerp towards another value. And so for rotation, I was also going to do something like that. Did we get rated? I don't think so, Casual. I think we're fine. Everything's fine. Don't worry about it. All right, so this camera control zone. All right, so this part here, camera, we are instead going to use our new camera handler.camera, which is much easier. All right, so when we enter the zone, so instead of having movement lerp rate, we're instead going to provide a speed, like a time for this movement to take place, and very, very good, Casual. Very clever. No category set. Even better. What I want to do is also include kind of a tween shape. This is this stuff right here. Linear is going to be our starting point. We're going to start with this. But I want to move out to being able to do these alternate variants. Cubic is probably going to be our default. Gosh, I love cubic curves. Every Saturday, we have a schedule now. If not camera, gosh, you better have a camera. You can't not have a camera. What are you talking about? Some cube rules. Cube rules. Every Thursday, he'll be streaming on Saturday. So the reason I did it this way, I'm remembering now, is because I was worried about overlapping zones. So I was saying, oh, I will increment every time you enter a zone, I will increment the target rotation so that we can have like nested zones of, oh yeah, the further you go, the more. But no, that's terrible. That's a terrible idea. So we're not going to do it that way. Instead, we're gonna have. We're not even gonna reference the camera directly. We're not gonna do that. Instead, we're gonna make helper methods in our new camera handler, such as. All right, there's no accessor. Let's see here, like change target. In this case, this is a degree rotation. How does that work? Crud, we still do need these zones. And we still need to be able to pan between things even when we're not in the zone. I guess we do need a target rotation. Dang it. A rotation offset. Ooh, that's ugly. That's ugly. Hang on, this is... I'm seeing the reason for my original setup, and I'm not liking it. Statistically, Al, it's a good chance it is. All right. Target camera rotation. But I want to do it over time. So I want to say, hey, over X amount of time, I want to be targeting a thing, which is the same thing. So it's not even a new target. It's the same target as the old target. We just have a new rotation. Can that work? So it'll be is in transition true, transition duration. I guess so. Rotation offset. Is that it? Oh, it was a good guess. Something like that, yeah. Rotation offset. The current system uses just a target rotation and a current rotation. And it adds that to the player's rotation, I believe. Somewhere. Maybe not. Oh yeah, we don't use the player's rotation. The player turns to face the camera, not the other way around. Jump the button. Oh, Willow. Bragging rights. Target rotation offset and current rotation offset, maybe? Well, no, I guess we could just go with target rotation and... Oh, no. Let's say offset. So on this camera controller, we're going to change that to that. We're going to remove this temp target stuff until later. This is going to be replaced by... our camera handler needs to have a new function. It's Mac. Adjust rotation. We take in a rotation change as a float. A duration of the change, also a float in seconds. And a transition type. This is going to be the trickier one. Because tweens have these and the easing types and the combination of that. But this is just a this is just an enum. Where is the actual function? Let's look up the Godot source code, shall we? Did you guys know we could just do that? You can just do that. That's allowed. Let's just find transition type. Where are they actually used? Show me the actual functions. Where are you doing the math? Where is the quint? Like, if you take all this code and you run it, it runs this window that I'm looking at. This whole thing with, like, help documents and buttons and gizmos. This is the source code for this program. Let's see here. Tween. Interval. Tweener. End tweener. Tween property. Text. It gets a tweener. Let's look up tween property. See if we find anything. Those are tests. Let's see, this should be the thing. When I call tween, what's the function I use to actually set it into motion? Yeah, exactly. It's code all the way down. All right, so you create the tween, and then you do tween property, and then that should just like run it. What does set trans? What does set transition type do exactly? Well, so that just sets the transition type here. Well, that doesn't give me much. I want to see where these different types are being used. Ease type. I want to see them in use, darn it. Huh. Get type, great. But then what do you do with that? Surely there's some like function that turns that into numbers. Start time and end time, okay. capture. Let's check this. References. Set trans, is that what I'm looking for? I'm trying to see, I want to yoink, that's the technical term. I want to yoink the actual mathematical functions that define all of these different transition methods, or see if there's somewhere that they're exposed that we can call them. Because all they are, they're a mathematical function that takes a value between 0 and 1 and returns a value that's, with some exceptions, between 0 and 1. That's what I need. The question is, where... Okay, add a paren to that. So we're setting the transition type here. We're exposing... Okay, that's the header file. Don't want that. Tween CPP. That seems like the most likely scenario. So that's setting what the transition is for this object here. But then somewhere along the way, we need to actually... Oh, step. Step. I bet this is it. Hang on. Maybe. Step. Like when you step a tween, surely that is the function. Step? Custom step. Okay, so I think step might be the right thing. How many steps do you do? I don't actually know a lot about what tweens do under the hood. But step seems to be the terminology for when we divide this into, say, 10 frames of action. It's calling that 10 steps. And so when we tell it, okay, step, you have done, we need to run it p delta seconds. Okay, and then it tells us how many steps, remaining delta, okay. That's rim delta. Oh, I love the Master Sword. Okay. If step is not active, then init finished. Well, if it is active though, write current step. Tweeners.write. Excuse me? All right, where'd tweeners come from? What's a tweener? I don't like that. What's a tweener? I'm just making up things. Start our tweeners. Okay, tweeners is a thing, right? Where is that property? This is me being very C# oriented and not familiar with C++ as much. Check your normals and start your tweeners. These are like new precepts. Started with no tweeners. I thank you, Willow. Thank you. Tweeners. All right, hang on. Going up here, I'm looking for tweeners. No, this comes from nowhere. This comes from nowhere. Oh wait, hang on, maybe. Okay, here we go. It's in the header. Okay, tweener is an object. should have a class. Tweener. Abstract class for all tweeners used by tween. Tweeners are objects that perform a specific animating task, like interpolating. Okay, let's check that in the docs here. Do we have tweener? Tweener. We have tweeners. Property tweener. So you can have a custom interpolator. Okay, we might be getting somewhere here. The interpolator. I'm looking for the interpolators. I want the code for the interpolators. Let's see here. Matrix. No. Okay, this is a lot of stuff that's not what I'm looking for. Interpolators. Where are the interpolators? Oh no, it turns out that there's a lot. There's a whole lot of oh wait, oops. Hang on, go back. I deleted too much in the search bar. Interpolator. Oh, is this it? Is this it? Oh wait, this is the header file, but we're very close. I think we're very close. See, there's lerp, slurp, and well, if it isn't lerp, slurp, and scaled slurp. Transform interpolator. Great. Cool. Where is the function? Oh no, is this the... Oh no, the math is big. It's not short little math that I thought it would be. Oh, two small numbers. Listen, guys, when the going gets rough, revert to lerp. These are less stringent tests than the standard Godot slurp. This is real code written by actual programmers. This is what they're demanding your respect for. They have played us for absolute fools. Apply the same test that will revert to lerp as is present in the slurp. All right, that's enough of that. All right, we're not gonna bother with it. It's not worth it. It's not worth the lerp. These are funny words. This is good content. Right. So, do we want to expose, like create a, do we want to use transition type and let's say ease in, ease out, and cubic. So that's our transition type. And easing is going to be tween.ease type, which is going to be tween.transcube. Oh, I mixed those up. Those are backwards. Ease in, out. Ease out in the function. Okay. Ugh. Just do the thing. All right. So when it's time to adjust rotation, so we need to do some kind of clear current or something. So let's have a clear current transition, which will take our camera and say, all right, if you have an old target, this should probably live here instead of there. So call that, and then set camera dot target rotation, whatever we called it, target rotation offset. Add in the rotation change to that. And take our duration and set it equal to the new target duration. All right. So now our camera control zone can say camera handler dot adjust rotation by rotation degrees. Do it over the course of 1 second. Now this thing needs to manage all that. It's gonna do that. It's gonna do some other things. I don't even know what else it's gonna do. Yeah. So, oh, and funk start transition. Like that. So camera handler is going to do all that stuff, and then camera dot start the transition. So it's kind of going to be our own custom tween code, but with a key difference, and that is that we're going to properly deal with the original value. We're going to scale between not the original value and the new value. We're going to scale between a moving target and another moving target. So we're basically going to do a weighted interpolation with a curve, which is maybe a lot to ask, but it's fine. If we're in transition, then current transition time, add how long it's been. We're gonna have to do some kind of weight function. Which is gonna be we've got our current transition time, so we can calculate get weighted ratio. We'll have our transition type, we'll have our easing type, we'll have our let's see here, transition ratio is going to be current transition time divided by transition duration. So that's going to give us a 0 to 1. We're going to clamp that just to be sure. just in case something goes really wrong with the rest of our code. It could happen. We're going to pass in old value and new value of type float. We're going to specify that we're expecting a float here. It could be a vector. Could we still do the same calculations if it is a vector? Maybe. We'll see. Mapped ratio. Leave that for later. Leave that for later. So we want to return a value. Let's say transition ratio is 0.5. Then we want to find the value that is 0.5 of the way between new value and old value. So we're going to take our new value, subtract our old values. Let's say between 5 and 10. So 10 minus 5. Multiply that by our ratio. Let's say we're going for the first 10% of the way through. So 10 minus 5. Let's say first 10% of the way between 10 and 20. Just so we're keeping... No, don't do doubles. Between 15 and 5. Okay. So now we've got 10 times 0.1, which is 1. Add that to old value. And that's our... There we go. So that should actually work on vector 3s as well. So we'll try that. Oh my gosh, it's lizards. Target rotation offset. Actually, let's just do this for now. Because this old rotation stuff, the old rotation was fairly straightforward, which was just lerp between our current rotation and our new rotation, and then set that value as current camera rotation. It's fine. So we're gonna start with something similar. Just set it equal to the current rotation offset, and rotation.y is equal to our current rotation offset. This should at least get us off the ground. No. Because target rotation offset, right. Replace that with that. Try again. No D. What is this one? Zelda Dungeon. Okay. We did in fact rotate the camera. Unfortunately, we didn't change the position of the camera. Normally you can do something like this with a spring arm. But when you're doing that, then you've got like child objects that you're trying to maintain to make sure they don't get lost, and we're just gonna do it manually. So how did the old code handle that? Some kind of rotate around, I'm sure. Here we go. Yep. Sure did. Instead of moving it back by distance to target, it was a rotated distance to target. Instead of current rotation, we're going to do current rotation offset. Okay. See if that works. Key cavern. Still not looking great. It's turning the right way, but it's just turning without actually moving to the correct position. Degrees to radian. No. Do we want degrees to radian? I don't think we do. We should stop using degrees for that. That's probably the problem. It was, in fact, the problem. Okay, and the player correctly snaps to face the camera. Okay, so now that we've done that, the next piece is this whole transition business. So we're in a transition. We're going to bump up our transition time. Instead of just outright setting current rotation offset equal to our target rotation offset, we're instead going to set it to a weighted value between not current rotation offset, but old rotation offset, huh? Ooh. Just like we have old position. This one's gonna be a little bit weird. From 0 to our target. So when we are saying set our target, that means we also have to set our old value. Dot target. No. I want the actual current rotation. I think. Il pentissimo. Okay, it's snapping. Very snappy. So it's in a transition. Current rotation should be the weighted value, which should slowly go up. Oh, and then this should not happen anymore. Right, take out that debug code. Insane. I did tell it 20 degrees. So there is that. But it read that as 20 radians. All right. And it snaps back to the correct value, it looks like. Even if I cut it in the middle of the transition. Okay, now it's doing it constantly. So notice right now, it's sort of start, stop, start, stop. So the next step is we're going to have it do something a little smoother. Which is where we're gonna swap out this. Right now it is doing a linear interpolation. We're gonna change it out for a cubic interpolation. I think, maybe. Oh boy. So Al, I'll do purple one. The purple one. Oh gosh, the lizards. I forgot about the lizards. So we want to create this mathematical function, this being our y-axis and this being our x-axis. In the bounds 0, 1, we want to create this cubic function, right? I don't know. I don't expect there to be many characters that we can plop over to, but there has to be some other group. Now, Bug Fables did not do a B-plot at all. Like, there were things going on behind the scenes, but you never get to see anything that the main characters are not actively observing. And I do feel like that weakened it a bit. It was just things were happening at you. You were having to do things. You knew other things were happening, but you weren't really privy to them. Which is, I mean, that's fine. So that doesn't look like a great cubic interpolation, does it? Exactly. Exactly. It kind of looks like two different quadratic angles here. Maybe we can do it that way. A little silly, but maybe. So treat this as one, do it a piecewise function. So what does that look like then? FF, is that extra good or extra bad? Because when I think of like AAA sounds good and F sounds bad, so I'm a little bit worried about what's being implied. Final Fantasy, that makes more sense. See, this should be something I just plug this into and get out a 0 to 1 result ratio. Okay, so this is the function. I feel like I kind of want to put this in its own thing. Very observant. This could be a utility thing. Okay, so a global. Create a new script. Call it. Well, what do we call it? What are these? Curves? Different types of curves? Sure, we'll call it curves. And we'll even make it an auto load. So all of these are going to take in a ratio and spit out a ratio. So the easiest one is constant. Easy. But then we're going to have our cubic ease in out, which I was really expecting. Like, that should just be a mathematical function, I think, but I guess not. I don't know. It's weird. What is the formula? Maybe Stack Overflow will have... Oh, they were doing the thing I was doing, which is two quadratic functions stuck together. Could be the Bezier curve that we could do. How's the Bezier curve look? I assume that's on here. It's not. Maybe it's just got a different name. Parametric function. Let's just do quad. Now, I don't know if we're doing the ease in out naming convention correctly. We can check. For a quadratic function, it would be the purple one, ease in out. Perfect. So if input is less than 0.5, then return 2 times x squared. Else return Stack Overflow. What do you say? Perfect. I love the way you think. I don't know, but then again, you got Crystal Chronicles. I guess let's just take an X. How about that? Sure. Crystal Chronicles was really good. All right. Curves is supposed to be a auto load, right? Did it not get, I didn't actually add it. Okay, let's see if that helped. Hello? Are you still not recognizing curves? There we go. All right, let's see if we get a smoother. Second half. First half looks great. Then it all goes downhill. Let's double check our math here. So at 0.5, we should get 0.5. Half squared is a quarter times 2. Yes, great. Invert that. 0.5. 1 minus 0.5 is still 0.5. 0.5 times 0.5. Quarter. Double it. Wait. 0.5. 0.5. Quarter. Oh. Oh. This seems wrong. Seems incorrect. Half. That goes to 1. And then at value 1, it goes to, so it's doing this and then down to this, which is not what we want. The curve I want here is this one right here with a 0 or a midpoint at 1 minus x, so that's not what we want here. One minus x times 1 minus x? Is that... okay, hang on. Let's just do it in written speech. I want x minus 1 squared, because that shifts the whole graph over by 1. Then negative the whole thing to flip it upside down, and then add 1. So now we can expand x minus 1. X minus 1. Not 1 minus x. Where did that come from? Let's try that. Let's try that math. That's not Pikmin. Close. It's still snapping at me. Is the derivative bad? Is that shouldn't be the problem. Like if it does like... I don't know, these should be two completely perfect, beautiful curves. In both of these... actually, let's pull up the JavaScript console so I don't have to try and do error-prone math in my head. If I set x equal to 0.5, then this first one equals 0.5. That's good. And the second one equals 1.25. Oh, did I not get the negative? Well, that still doesn't look great, does it? .75. Uh-oh. All right, Google, graph something for me. 5. Yeah, that's not right. Oh, because my overall is not right. No. Yep. Well, then this isn't right either, is it? If I graph that, that doesn't look right. Because that only goes up to 1. But it does land there, so this one would have been right. If what? If we scoot x over a bit? X minus x squared is what that is, which isn't great. Okay, I've got some points. Here we go. Quadratic function calculator. I'm not going to do this as a linear equation. I'm just going to... given the vertex point... Okay, I know my vertex point needs to be 1, 1. And I want to have a point at 0.5, 0.5. That should be enough. That looks like the one. Okay. Should be -2 times x minus 1 squared. Does this support this syntax for squaring? I hope it does. Plus 1. We're going to find out. Ah, there it is. Oh, that's nice and smooth. Love it. All right, cool. Beautiful. Beautiful. It's a start. We've got our quad ease in out. Camera handler does not support this mess yet. Nice and quadratic. Okay. So this no longer does this. Let's go to another map that has something for us to focus on. Let's get things really busted. Let's watch everything break. Specifically, there we go, right away. Set bounds. Cameraman and Camera Max. That is another thing that we need to support. Our new camera needs to support Cameramin and Camera Max. This code worked pretty well. But something I didn't like about it, and we're gonna adjust things to fit this, is I was putting a bound around the camera rather than a boundary around the target. A whole new camera from scratch? I wouldn't say it's really new. It's mostly pieced together from old code. We're more of redesigning it. Like, we're not changing anything about how pixels are drawn to the screen. I'm mostly just changing how does the camera object move in relation to the player. When the player is moving around, you can just say, camera is exactly this far away from the player at all times, and it'll just perfectly track the player, and that looks very stilted and gross. Exactly. It was gonna need it. And we built enough pieces that we're gonna be able to handle pretty much everything. Yeah, and we've kind of designed some of those already, and they're gonna have to be shifted a bit for the new code. But it was kind of a pain to work with. All right. We're gonna do something with this vaguely. We have our target position, but camera target position equals target dot global position, but we're going to adjust this to fit within the camera boundaries. So now this is going to be operating a little bit differently from the last one, because previously previous way, so there's our ground, and here's our player moving around. Here's our player, and then our camera is looking at the player. Beautiful. So the old code was saying, all right, player, you can go anywhere within the grounds. That's fine. But camera, you have your own separate boundary box consisting of 2 points. We put a point like here and a point here. Hear me out. And we said, all right, camera, you have to stay in the rectangle created by those points. And that typically works. But that is annoying to position, as you can see. So our new setup is going to say, all right, camera, you can follow your target, but if your target ever goes outside of this red marked zone for whatever reason, then you yourself will still pretend that your target is still bound to that red zone. Even though the target can walk away beyond that, the camera is still going to be looking right here. So that's going to be the new way that we're doing it, which should be easier to set up. Because of course because that's going to better handle rotation for one thing. All right, what's the next piece that's broken? All right, so we should be able to have a basic, yeah, so the camera minimum and maximum. Wonder if we can build in the boundaries of the camera a little bit better. Because right now, camera minimum and maximum are set up to be like, oh yeah, in here, which of course the player is always in that zone. How many mini games will be in this game? I would like to have a handful of mini games. You gotta have your mini games in these sorts of things. It's games all the way down. If I walk over here, does the camera ever stop? No, not really. Where is the camera minimum and maximum in this zone? Oh, it's, let's see here. Camera bounds. Show me the camera bounds. Minimum, over there. Maximum, over there. Okay, so this is fine. I'm gonna try something here. I just want to make sure this actually works for one thing. Me too. No, it's actually not respecting the camera bounds yet. Why not? Because we're not using global? Oh, those are top levels. That's by default global. And that's global. So how are we allowed to do that? Still a good game though. Now I had some mini games. Okay, -10. -10 is our zone, is our target. Current position of our camera is -29. That may be offset by something though. Camera. 10, -16. Well, that feels like that is okay. No, it's changing it. Oh, but we're not using it. Haha, right. Right. Don't use target global position. Use that. There we go. Now we have our boundaries. So now we can move this back to where it was, and we're solid. So one thing that would be nice is to automatically stop before we get to the edge. Just don't know exactly what that would look like. So I want the camera to stop scrolling left, like right around here, actually. How did it do that? I didn't do that. How is it doing that? Oh. Right. Because the code is already factoring in an additional 3 to the left, 3 to the right. And also apparently some up and down. The Z-axis, probably not necessary. Okay. Well, cool. I guess that will work. We'll accept that. All right. The next big one. Entering a building. This is not going to work because we literally have not plugged in the code for changing camera target. Boom, right there. Target camera rotation. Takes in rotation degrees. So, similar to our camera focus zone. No, our, what was it? Camera control. Camera handler dot adjust rotation. And I guess, you know what we could do is give this a default duration of 1 second. Just to make it even easier to use. All right, so building. Normally call that, but don't do that anymore. Do that instead. Get rid of that, get rid of that. And this is camera handler dot. Because we don't need the camera itself anymore. The camera just is. So don't waste time gathering it. Okay, then we also need the targeting for the camera. So right now it's going to continue targeting the player, and that's okay for now. Actually, that's really nice and smooth. So our old way, you might remember that when we went into a building, that does look really nice for now. That's not how we want this to work. Because right now, we don't want it, like, letting us, like... This right here, this movement, I don't like this. It breaks the illusion a bit for me. Because now it's like, why can't I walk through here? Oh, right, I'm in a house. But when the camera locks in, like, right here, then it's like, okay, this is the entire world right here. So the big thing that we're wanting to avoid is that in the old version of the camera, when we went in through a door, it would snap before we got inside. It would snap to the new camera angle, and that created some big problems, and we don't want that to happen anymore. So we're gonna have a new camera adjustment thing. I guess we want to adjust rotation and target. So we're gonna have a rotation change and a camera target, which is some node 3D of some sort. So we're gonna change our current rotation, but also we're gonna do something else that I don't know exactly what it looks like yet. Camera handler. Adjust target and rotation. Oh, do we want to do this individually? Why were we doing it? Because we would clear the current transition to handle the case wherein we snapped back and forth. Do we want these to be on separate timers? I don't think I do. I could. These could exist on separate timers. Like have a transition for rotation and potentially a separate transition for target position. Do we want that? I don't know that we want that. Let's try it. Let's try it. Never need a camera in a video game. They don't have to be this complex. Like I showed at the beginning of the stream when we first started the rewrite, it can be as simple as just point to player. In fact, you don't need any code at all if you want to do that, because you can just attach the camera and say, all right, the parent or the player owns the camera object. And what that does in most of these node-based engines is just every time the player moves, the camera moves with it. I prefer not doing that way because I want to have finer control over things. Like I want the camera to be able to slide around and look ahead and all this other stuff. Okay, so we're gonna change a few things. We're gonna have rotation transition, and then current rotation transition time, and is in rotation transition, and then a whole nother set for target, for when we're changing our target. All right. So for rotation, let's update those. Duration. Change this. Start rotation transition. Current rotation transition time. Rotation. Okay. So that's now all separated out for that one. Next is camera handler. Adjust target. We're just gonna say adjust target now. And this will be not with this. Start rotation transition. All right, looks much better. Adjust target. Or I guess set new target is what it's gonna be called. Set new target. And what that's gonna look like. Clear current target transition and set target start target transition is in target, current target, target transition, go. So for camera handler, we're gonna clear target and start target. And the duration is going to be this one right here. This is a little silly, probably overbuilt for what we're doing. All right, now for the actual thing we want to do is when we change to a new target, old target becomes the new target. Becomes target. Additionally, camera. Additionally, we're going to set up our old target position and rotation. What did I mess up here? Oh, camera target. Old target position. We're going to take whatever our current tracked object was. Because we're always going to be targeting something. Do we care about this that much? Yeah, because something might delete this immediately. Identifier target. Camera.target. Old target. Rotation. So we're going to snag this before anything happens to delete it for whatever reason. Okay, so now we can set the target. Now we have to actually respect the target. Rotation. Why is that? Okay, right here. If is in target transition. Oh, I need something so that we can snap out of a target transition as well. Or any transition. If we're in a transition, then update our current transition time. Current position. Camera target position. That's what we are going to be trying to figure out. We're going to default to our current position. If we are in a transition, then our target position is actually a weighted value. Okay, this can be float only. And we're going to make a new version of this code that is specifically for targets. Node 3s. No, vector 3s. Sorry. And yeah, the rest of the code is going to be identical. Get weighted target value between our old target if it exists. Let's assume it does exist. Actually, what we'll do is if oh gosh, what's the function for if like is in tree or something? No, it can't be that. Is let's see here. Is freed. Is instance valid? That's the one. If old target actually exists, then let's update our values here. And regardless of whether it exists or not, we're going to move from the old position to our new target object's position, global position. Okay, I think that handles that. Maybe? That might break. It broke. Oh, because I never actually set new target. There we go. And this. Here we go. This one's going to be a fun one. Our camera handler needs to know about the player. The default target. So whenever we set up a camera, we're going to make sure that we are setting up our default target here. This is what we can revert to. So we're going to have, instead of set new target, we're also going to have a revert to default target, which is basically going to be the same code as before, except we're going to call it with player as the value. We go. Now we can just say revert to default. All right, what breaks next? Add camera. Right, I shouldn't have said character body. I should have said node 3D. I was just trying to be more specific, and it turns out I was giving it the wrong value. Oh, well, that's an interesting view. What? What? Let's go back to our test scene and see if anything's weird. Yes, something is weird, actually. Something is, in fact, weird. Okay, that's got to be on our code here, maybe? If we're not in the transition, we're just setting it to our current position, but that's not what we want. We're not in a transition yet. Just always use our current target's position. Oh yeah, that should just be the default here. Okay, so this should work here. No, it does not. Why? That's some debug code here. Tell me why. Okay. Target is at 0, 0, 0, basically. Okay. We're at 038. That makes sense. I move. All right. Now I'm over here, but I'm still there. Camera target position. Is that having issues? No, it wants to target it. Not in there. Print camera min. We do have a min apparently. Do we have a max? Yes. Okay. Camera min and camera max are locked in for some reason at vector 30. Because I guess they're just not initialized. All right. You just have to trust me that they're going to be vector 3s. Okay. That looks fine. Move over here. Let's get the next crash. All right, that looks great. Go into a building, break it all. What is the problem here? Adjust rotation has been called with transition duration. Did I give this the wrong? It's now rotation transition duration. Yes. Right, we changed some property names. Okay. Next up, breakpoint. Don't need that breakpoint. That was a mistake. Continue. Oh, silky smooth. No, actually it's not working yet. It's not targeting. It's still targeting the player. So we are not there yet. Yeah, it's not what I want. Why are we not targeting the camera target? Oh, I never set the new target. I set old target. Old target should be camera.target. There it is. Oh, that was beautiful. Yes, that's what I wanted it to do. Oh, that's silky smooth. Look at this. Okay. Look at this nice smooth. Oh, that's good. Oh, it just locks into place. Ooh, that's nice. That's nice. Okay. Excellent. Excellent. I think the next item would be, could we add a little bit of code to move the focus point towards where we are heading? That might be asking for too much, at least now. Oh, that was a nice little transition. All right, let's make sure these work all right. Here we are. Why did I pop into the air when I got inside? And there too. Actually, I know why. The interior and exterior locations are misaligned with the ground. Oh, that's pretty good. That's pretty good. I like it. Now this will probably not work. Oh, something broke. Ah. Perfect. Okay. The camera tween code. So this is a cinematic step for when we have a cinematic event in the game. We have multiple things we can do, such as move the camera, trigger a dialogue tree, other things. Ooh. Yeah, it's a little mini movie in the game. Something is happening that you get to watch. So we can get rid of most of this stuff. Ooh, callbacks. We need to implement callbacks. Right. In. All right, so that's going to be in our new camera code. So we're doing rotation and position separately. Do they have separate call? They shouldn't have separate callbacks, should they? Camera tween was go to a node, which is good. We can work that into our new one pretty easily. Okay. Is in rotation transition. If our transition time exceeds or matches our target duration. No, wait. Our current. What's this? What is our duration? Our rotation transition duration. Then is in rotation. No, then clear rotation transition. And I guess also do a call. No callback for this one. But for the other one, yes, callback. We'll add a callback for changing our target. Signal? Don't even need it. It's a 1-to-1 here. Static function on target change done. We could have some kind of signal passing because the cinematic right here, we want to be able to do the callback. Hopefully we're never going to get 2 callbacks at once, but we need to be ready for that. Like 2 separate camera things kicking off at the same time. We want to make sure we're accurately handling that. But we can pass in a callback. I think, okay, I want to do that as a signal. So to do a signal, we expose it as a method and then call it when it's appropriate. So we can just have a signal on target change done. And then we can emit it. We're also going to emit it when we are starting a transition. If we're already in a transition, then I guess we need to emit that the change is done. Does this actually make sense as something to do? Or should we just call it on the camera handler? Signals kind of feel like overkill for what we're doing here. They're very powerful. All right, on target change done. Do a thing. Callback, should that be a list? When I say go to this target, and it says, okay, I'm there, then it should call it with the target. It should say, okay, I made it to the target. Yeah. And then we can have a dictionary, I guess. A callback dictionary. We don't have typed dictionaries yet. Okay, so when you set a new target, we should have the option of registering a callback. That says, okay, when you reach this target, do this callback. And all we're gonna have to do here is say current callbacks is callback dictionary sub-target. Aw, yeah. Welcome in GQ. How does the get call work if it's null? Oh, I can just do get key. Defaults is null, but we're going to be explicit there. If there are no callbacks assigned for that one, is there a set? No, you just use the default. This. Make it a list of callback. We're going to be able to have multiple callbacks. Else, take the existing list and append the callback. And that's it. So, when a target change is done, look for callbacks for that target. And if there are some, actually, let's default to an empty list. For each of the callbacks, call it. All right, so we're going to register callback when we have this camera tween business. Target. Set a target. Go to the target position over the course of this. And when you get there, do a callback. Dabble Worlds levels. Yay! Now what's all this about rotation change? Oh, that's an export value. So we can also do adjust rotation by rotation change over the course of duration. Okay, so we don't need all this anymore. We sure as heck don't need all this anymore. Wow, that's much less code overall. That's it. That's the entirety of it. Oh wait, no, that's on run. Ooh, wait. Doesn't a cinematic step need to... Wait, no, it's not process, it's run. Run happens once. Okay. Cinematic step gets called by something else. The cinematic code calls the step. It calls the run, and then it makes a callback chain. It's just a callback chain. Okay, that might take care of that. We are working through, bit by bit, rewriting this camera handling code. And you know what? The building entry looks a lot smoother, so I'm already pretty satisfied. Now this is probably going to not look right. I don't know if it'll break, but I don't think it'll look right. Oh, actually. Oh, nope, we're not quite there. We're a little off. Yep. And then, okay. What broke here? Global position on target in the camera code. We have no target because we set it to null. Someone around here tried to set it to null. That should be easy to fix. If camera target is null, then use our default target, which is the player. All right. Progress. Okay. This cinematic pan moves over to the flower focus point, apparently, which is supposedly right there. I didn't feel like we were targeting that spot. Can I add a mesh to that? Okay, so now we have a clear indication of where we are focusing. Oh, I know what it is. Well, it is focusing, okay. Yeah, no, it is focusing that exactly. Fortunately, that's not what I wanted to target. I want to target this over here. All right, here we go again. It's yours, Al. Word for Al. That's breaking in a weird way. All right. It's good. The rainbow is not visible. We need to go all in on that rainbow. It was him. And the camera pans back. And I'm still stuck on here. Uh-oh. Uh-oh. No, the bot just does that. Don't worry about it. All right. Good. Mostly. So, issue. Why didn't it let me go after the cinematic was done? Cinematic. Okay, so cinematic happens. Callback. Release gear spinner. Supposed to be called. But it wasn't, I think. We'll try it again and find out. It's almost time to be done for the night. Mario, wings to the sky. Great, good job, Mario. Good for him. I should work on this rainbow. This rainbow is too subtle. It's like you can kind of see it if you know to look for it, but otherwise it's like it's nothing. It did not release me. It did not release me. So this callback did not get called. Why? Like the cinematic got run, so it definitely not there. Flower grow animation. Rainbow. Where's our rainbow? Here we go. Right here. Transitions to 20%. No. Let's go 50. Well, not percent, but. Justice for Goose. Oh, okay, so that did get called. Rainbow. But then does not call the final step. Why not? Cinematic callback should be not a problem. Yeah, in the cleanup step, right here. Very mysterious. Alright, so watch for the cleanup of the cinematic in the output window. We're gonna see what we get here. We've got... It's not doing the cleanup step at all. Ooh, uh-oh. Okay, I broke something. All right. A cinematic step. Oh! I know what it is. I know what I've done. So for instance, yeah, we're always supposed to do callback.call. That means that this register callback is what's failing here. Well, we've registered the callback, presumably correctly. But on target done either is not getting called or our callback dictionary does not have its callbacks in it. Okay, yeah, it's because we messed with the callback stuff. The callback chain. All right. On target change is done already. What? Okay. Null goes to, oh, null. It doesn't handle null. If you pass in a target of null, then that's bad. For one thing. For another thing, we should actually remove callbacks after they are performed. So once we get the callbacks for that target, how do we remove a key from a dictionary? Delete, remove the dictionary, erase. All right, so after we have successfully done our callback, then we can erase. I worry that this is gonna be a thing. No, it'll be fine, but we do want to do this player adjustment. All right, that hopefully squares out the camera changes as they pertain to room F. We're gonna have to work through all our previous rooms that do any kind of special camera stuff to make sure that everything is working correctly under the new system. Because the new system is the gold standard. It's what we're gonna be using for hopefully forever. That needs sound effects. That needs the flowers need to be better. Oh, okay, well that's something. Ah, we have more camera code here. So what is this? Cinematic code in general. Does not need to do anything with the camera, I don't think. I don't know that this should have swap to default camera. That should just be the natural state of running a cinematic. Suspicious. Don't like it. All right, we're gonna get ready to do a raid. Who are we gonna see tonight? Dove is on, Imp is on. LaPlume. Pop up. Yeah, we're popping off. We did it. Yeah, let's go. That's what I'm talking about. All right. That's a little bit violent of a transition, but it's all right. Cool. Nice. Let's get out of here. Let's go. Look at this guy. Look at this chill guy here. Don't have a ton of time to hang out, but let's go pop in, see what Imp's up to. He's been working on a Survivor's like for a bit. It's been fun to kind of watch the process. I like to see things as they come to fruition. Just the slow and steady progress. You know what? Maybe that's what I like about multiplayer Minecraft. Is you just see somebody starting to work on some big structure, and then every time you log in, it's like, oh, there's another tower, and there's another one, and now there's a big wall here, and ooh, what's that gonna be? It's fun. That's what I like. Thank you all for watching. We've got more work to do on the camera next time, but it's doing a lot better now. Like the building, if you go back a week and look at me walking into these buildings, you'll see a stark difference. Oh, that's smooth. It just kind of. Oh, it's so good now. All right, everyone, have a good night. I will be back Friday. I'll see you then. Good night. Bye.